Example 3 gives us another opportunity to use the side splitter theorem. We have two parallel lines in a triangle, creating two triangles. So we can use that 6 over 21 will equal x minus 1 over 3x plus 1. It's important to be careful as we're doing our cross products that we are using the distributive property. So I have 6 times 3x plus 1, and I have 21 times x minus 1. That gives me 18x plus 6 as I distribute to both pieces, and then both pieces on the other side gives me 21x minus 21. I'm going to go ahead and subtract 18x from both sides of the equation and also add 21 to both sides of the equation. If you like to do that in two separate steps, you may go ahead and do so. That makes it 27 equals 3x, dividing both sides by 3, and I get that x equals 9. In part B, we have all kinds of things going on. We want to know what the value of x is in triangle PQR. So seeing that these two lines are parallel, right here and right here, we can use this piece, the x plus 2, over, and we need to use this whole piece up here because we don't know that y is parallel. So we're going to say that this is 16. And then on the other side, we have x, and then we need the 9 and the 3 together, which is 12. Using my cross products, I get 16x, and don't forget we need to do distributive property, so it's always a good idea to write it down and not try to do that in your head. So I get 16x equals 12x plus 24. Subtracting 12x from both sides of the equation gives me 4x equals 24. Dividing both sides by 4 gives me that x equals 6. Let's go ahead and work through the try it together. Using that same triangle, we want to know what is the value of y. When we look at these triangles, we see that, I'm going to go ahead and erase this piece for a second here. When we see that x equals 6, we know that this piece right here is 8. And that makes this part from here to here 12. And over here, we see that x is 6, making this part from here to here 9, which means that this is a midpoint. And if that is a midpoint, then we know that this line will be parallel to this line, and we also know that y is going to be half of 30. And so we know that y equals 15. How do we find the value of z? We're going to need to use the 30 and the z. And then since this is a whole piece of a triangle and a whole piece of this triangle, if we did 30 over z, we need to use 24 which is the whole thing, and 16, which is just this piece from here to here. If we remember, that was 16. That gives me 24z, and 30 times 16 is 480. Dividing both sides by 24, I get the z equals 20.